Okay. All right. This is going to be the exam number 2 we are going over, and if you have any questions after this video, then you can always come to class and ask questions. Okay. I will try to go over these questions with the detail, but if you don't understand anything, you can just come to class and ask me your questions. So first question was the simplify the expressions using only positive exponents. So as you can see on the question 1, there's a couple of ways we can do that. You can take care of the inside first, then apply the negative exponent on the outside, or you can just take care of the outside first, then simplify the inside. It's up to you. So the way I'm going to do here is that I'm just going to take care of the inside first. Okay, so here we go. I'm going to take care of these exponents inside, so minus 5 is going to be still there. Then I'm going to apply the square inside, so I can remove that parentheses. So I got x to the minus 6, and then y to the square. And then we still have a 10, x squared to the y to the negative 1 at the bottom. Okay. Now we're going to apply the negative 2 to everything inside. So I have a minus 5. I'm going to put it in the parentheses here, then negative 2. X to the minus 6 to the minus 2. Now remember, we are applying the power rule here. Okay, so minus 2 has to apply everything inside. Then I have y squared to the minus 2. And we do the same thing at the bottom here. So you got 10 to the minus 2. X squared to the minus 2. And then y to the minus 1 to the negative 2. All right. So we're just going to, remove the parentheses, and we just accept the constant term over here. We'll take care of that a little bit later, but let's just take care of all the exponents on the variables here. So here on the left, I have minus 5 to the negative 2. If the next term is going to be minus 6 times minus 2, so that will be x to the 12. And then you got y to the square times minus 2, you get y to the negative 4. Okay. We have a 10 to the negative 2. We still haven't taken care of that yet. Alright, so now next one is going to be 2 times minus 2. We're going to get what? X to the minus 4. And then we have y to the minus 1 times minus 2. We're going to get y to the square. Alright. Okay. So what we're going to do here is that, we are going to look at each term now, then we're going to apply the negative exponent rules. So whatever you see minus, we're going to flip it. So if you have anything at the bottom with the minus, then we're going to put them at the bottom. If you have anything at the top with a minus exponent, then we're going to bring it to the bottom and make it positive. Okay, so let's just do that using the constant first. So if you look at the minus 5 to negative 2, I have a negative 2 there. So I'm going to bring it to the bottom. Then I'm going to make it positive. So I have minus 5 to the square. And then same thing for the 10 to the minus 2. So since I have a minus 2 at the bottom, I'm going to bring it to the top and make it positive. So that would be a 10 to the square. X to the 12 is already positive. but x to the minus 4 is negative at the bottom, so I'm going to bring that up to the positive 4. And the bottom I have a square, positive square, so I'm going to just leave it there. But y to the minus 4, I'm going to bring it down to make it positive, which is y to the 4th. So if I expand, the 10 squared is going to be 100. I have x to the 12 plus 4. You have to apply the product rule of exponents. Minus 5 times minus 5, you get 25. Then y to the 2 plus 4. So 25 goes into 100 4 times. So we have a 4 x to the 16 over and y to the 6. And that should be the answer there. All right, let's look at the question number 2. So the next question was factor the following polynomial completely. Now remember, the completely means that everything has to be broken down into the simplest form, right? So here I have what, 12 x squared minus 48 x plus 45. So as I mentioned, whenever you do any type of factoring, you always have to look for the common factor first. Okay, so here I can take out the 3. So then it's going to be a 4x squared minus 16x plus 15. Okay. Now here we're going to have to factor this guy here, right? Right here. So I'm going to break this into 2x and 2x here. 15, I'm going to use the 5 and 3. They both has to be negative. Because we have to have a minus 16 in the middle, so if I cross multiply like this, I get minus 10x, and cross multiply like that, I get minus 6x. So if I add these two, I get minus 16x. Alright, so that looks good. So the entire factoring becomes what? 3 times 2x minus 5 times 2x minus 3. Okay. All right, let's move on to the next question. Question 3. We want to simplify the rational expressions. Okay, so let me just write that here. So question 3. So we have 2 over x minus 2 over x minus 1 and plus 3 over x minus 1 squared. So in order to simplify the rational expressions, we need to come up with a common denominator, right? So we can make that everything same denominator. So it seems like you have x minus 1 already because it belongs to the x minus 1 square. So this is going to be x minus 1 times x minus 1. So it seems like that least common denominator, or common denominator, or greatest common denominator. Let me just put it in there. Common denominator is the x times x minus 1 times the x minus 1. but we can rewrite that x minus 1 times x minus 1 with x times x minus 1 squared. So we're going to have to make the denominator look like x times x minus 1 squared. So the first term over here, we are missing x minus 1 squared. So I'm going to multiply that. So x times x minus 1 squared. We're going to do the same thing on top. Okay. Minus. The second term is missing x and x minus 1. So we're going to do that. So 2 over x minus 1 was there already. Now we're going to have to multiply it by x times x minus 1. And we're going to do the same thing on top, x times x minus 1. And the last one is going to be missing x. So we're just going to multiply the x to the top to bottom here. Now one thing you're going to have to remember here is that this is an expression, rational expression, so therefore you cannot eliminate the denominator, okay? Unless you have equation. This is not an equation. It's not equal to anything, right? So you cannot eliminate the fractions. So now we are going to have, I'm just going to draw the big, long line over here. And as you can see that the bottom denominator becomes x times x minus 1 squared. So the only thing that we have to do now is multiply these out, and we're going to have to combine the like terms, okay? And then we're going to have to combine them. So let's just look at the first term, x minus 1 squared. So let's just go to the box here. And we're going to find out what x minus 1 times x minus 1 is. X minus 1 and x minus 1. So you have x squared minus x minus x. This is going to be plus 1, right? So then we're going to have to multiply that by 2. So I'm just going to do that. You got 2 times x squared. You got minus 2x over here. So if you multiply that minus 2x times 2, you got minus 4x. And the 1 times 2, you get 2. Okay. Now the next one is going to be have to be careful because you got minus in front of it. Now you got 2x in the in the front, then multiply to x times minus 1 there. So you got 2x squared and the minus 2x. Then plus 3x. Okay. All right. So what we need to do here is that we're going to have to combine some of these terms and make it simple as possible. So I'm going to rewrite the top, removing the bracket over there. So I have 2x squared minus 4x plus 2. Then I have what? Minus 2x squared. I'm removing the bracket over here. Then you got plus 2x. Then you got 3x. Okay. All right. So if you look at the 2x squared and the minus 2x squared, it goes away. And if you look at the here's a 2x and here's a 3x and here's the minus 4x. So you got 5x minus 4x, you get x. And the only constant term you have is going to be plus 2. And then you get x times x minus 1 squared. Okay, so that should be the answer. Okay, So now let's move on to the question number 4. Alright, question number 4. We need to solve the inequality. You got x plus 12 over x minus 2 is going to be greater than or equal to 0. Now remember that we need to come up with the interval points. So there's two ways you can find the interval point. You can make the rational equation equal to 0, and the other one is going to be find out if there's any x value that makes the rational equation undefined. So the first, we're going to make this rational equation and going to solve for the unknown. So here x plus 12 over x minus 2 equal to 0. And we're going to multiply the both sides by x minus 2. Okay. And if you do that, then you get 0 times x minus, you still get 0. So you got x plus 12 equal to 0. So x is going to be equal to minus 12. So one of the interval points is going to be minus 12. The other one is going to be that if you look at the denominator here, okay, x minus 2, right? That x cannot be equal to 2, because 2 minus 2 you get 14 over 0, so you get undefined. So that's another interval point, right? So because x equals to 2, okay, will be another interval point, because that x equals 2 make this equation undefined. So we have two interval points here. So I'm just going to draw this so you guys can see. So here's the x equals to minus 12, and here x is going to be equal to 2. Now we don't know still whether the minus 12 and the 2 is going to be included, so we're going to have to evaluate them as well. We're going to have to find the test point here. So over here I'm going to choose the test point. Let's just x equals to minus 13. Over here the test point, I'm going to choose x equal to 0. And over here test point, I'm going to choose x equals to 3. Okay, so we're going to evaluate these points to the inequality, the original inequality. So let's try. So here x equals to minus 13. So if I plug it in, minus 13 plus 12 divided by minus 13 minus 2, is this going to be greater than or equal to 0? That's going to be on the top you got minus 1, and the bottom you get minus 15. So minus 1 over minus 15, that's 1 over 15, which is greater than 0. So we're going to shade this area here. Okay. Alright, next we're going to go to the next test point. So this is going to be x equal to 0. Let's plug that in. So you got 0 plus 12 over 0 minus 2. Is this going to be greater than or equal to 0? Now that's going to be negative 6, so that's false. Alright, so we are not going to shade anything over there. Now when x equals to 3, let's just plug that in. So you got 3 plus 12 over 3 minus 2. Is this going to be greater than or equal to 0? So you got 15 over 1, which is greater than 0, so that's going to be true. So we're going to shade that area as well here. Okay. Now we need to find out, see if these two interval points are included here. So let's try the x equals to minus 12. So if I plug in minus 12 plus 12 divided by minus 12 minus 2, is this going to be greater than or equal to 0? Well, on the top you got 0, so 0 divided by minus 14 is 0, so 0 is equal to 0, so that's going to be true. So we're going to have to use the bracket here. Okay, so use the bracket. Now let's try the if x equals to 2. So here x equals to 2, plug that in, you got 2 plus 12 divided by 2 minus 2. Is this going to be greater than or equal to 0? That's false, that's undefined, right? So here we're going to have to use the parentheses. Okay? Now all you have to do here is that we're going to have to write it in mathematical notations. Okay, so from the minus infinity, we're going to come all the way to the minus 12, but minus 12 is included. Union, because we have another area of the shaded region. So now from the 2 is not included. And going all the way to the positive infinity, which is not included. Okay, so this is going to be our answer using mathematical notations. All right, now let's look at the next question, question 5. Okay, so here the question 5, we need to solve the rational equations. So I have x minus 2 over x squared minus 7x plus 10 equals to 1 over 5x minus 10 minus 1 over x minus 5. Okay, that's what we have here. So, because this is the rational equations, we want to eliminate the denominator. So we're going to have to find out what would be the LCM, this common multiple here, right? Now, if I factor the x squared minus 7x plus 10, and that's going to be same as what? 5 and 2, but they both negative, right? Because you got minus 5x and you got minus 2x, and if I add the minus 5x minus 2x, I get minus 7x. So we can rewrite the left-hand side term over here. So I have x minus 5 times and the x minus 2, and at the same time the first term on the right is, if you just take out the common factor 5, then it just becomes x minus 2 minus, then you got 1 over x minus 5. So you can say that the least common multiple that we're going to have to multiply is 5 times x minus 2 times x minus 5. Okay, so that's what we're going to do. So this thing over here on the left hand side, now it becomes, we're going to multiply everything by 5 times x minus 5 times x minus 2. Okay, to the everything that you see on the right hand side here. So we're going to have what? X minus 2 over x minus 5 times x minus 2 equals to 1 over 5 times x minus 2 minus 1 over x minus 5. Alright. We're going to multiply this quantity here, 5 times x minus 5 times x minus 2 to one term at a time. So let's just look at the first term. So you see the x minus 5 and x minus 2, so they cancels out. Okay, so we're just going to get 5 times x minus 2 on the top. And the first term on the right is going to be, you got 5 and 5 that cancels out. And the x minus 2 and x minus 2 cancels out. So the only thing that you're going to get is going to be x minus 5. And the last one, you're going to get what? X minus 5 cancels out, giving you 5 times x minus 2. Alright, everything looks good. So we're going to have to solve for x. So I'm going on the left hand side, I'm going to multiply that out. I have a 5x minus 10 is going to be equal to x minus 5 minus 5x plus 10. So let's just take care of the right hand side first. So you got x and minus 5x over here. So I have a minus 4x. And then I have a minus 5 plus 10. I get positive 5. On the left hand side, I have a 5x minus 10. We're going to add 4x on both sides here so we can isolate the x. Okay. So then on the left hand side, I have a 9x minus 10 equals to 5. And then we're going to add 10 on both sides. So we have 9x on the left, then 15 on the right. So now we're going to divide the both sides by 9. Okay? And then x becomes what? 5 over 3. Okay? Because you're going to divide both top to bottom by 3. Okay? So the answer should be x equals to 5 over 3. Now, as I mentioned that, because of rational equations, you can possibly have undefined value so that there is no solution for the given equation there, right? So my suggestion was that you need to put this back into the original equations. I'm just going to do that. I'm not actually going to go through it, but if you have, try the x equals to 5 over 3, make sure that, this does not give you the undefined value. So what you need to do here is you're just going to have to plug this back in here. And the 5 over 3 minus 5. And the 5 over 3 minus 2. And 1 over 5 times 5 over 3 minus 2 minus 1 over 5 over 3 minus 5. So if you actually plug this in and evaluate this, you will get that left is equal to right. Alright, so now let's look at the next questions. So that would be question number 6. So question number 6 is the use the both synthetic and the long division to divide the polynomial. So let me just go through that. So the easiest one is going to be the synthetic divisions, but you're going to have to be careful though, right? So let me just do the synthetic division first. So let's just collect all the coefficient from the dividend. Here we only have what? X cubed and negative 81. So everything else I'm just going to put 0 in there. So the first one is going to be 1. That's going to be x squared. X cubed. X squared, I don't have anything. X, I don't have anything. Then I have minus 81. And then we're going to divide by x minus c. So in this case, it's going to be 3. So bring down the 1. Okay. Now cross multiply, which is a 3. Okay. Now then you're going to have to now let's add these two. Okay, I was off a little bit here. So that's going to be 3. Now cross multiply, which is a 9. So that's going to be 9. And then 3 times 9, you get 27. And if you add these two, you get minus 54. So as I mentioned in class, after the divisions in the synthetic division, the first term is going to be always 1 exponential power less than the original polynomial. So this now becomes x squared. And that's going to be 3x plus 9. We do have a remainder, minus 54. And you're going to have to divide it by the divisor, in this case x minus 3. So that was the synthetic divisions. Now let's look at the long division. Okay, so now remember that just like synthetic division, long division, we don't have any x squared term and the x term there. Okay. So let's just do that. So here's the x minus 3, then you got x cubed. I'm just going to add the placeholder. So you got 0x squared plus the 0x, and then you got minus 81. So x goes into x cubed, x squared times. Okay, so then you got x squared, x cubed here. Then you got minus 3x squared. And you're going to have to subtract that from the top. So x cubed minus x cubed is going to be going away. And the 0x squared minus 3x squared, you get 3x squared. And we're going to bring down the 0x over here. So x goes into 3x squared plus 3x times. So then we have 3x squared minus 9x. Okay. And subtract that from the top. So you got 3x squared minus 3x squared, you get 0. And then the 0x minus 9x, you get positive 9x. Then you got minus 81. And how many times x goes into the 9x? Okay, so that would be 9 times, right? So you got 9x minus 27, and you subtract that from the top. 9x minus 9x, let's go away. And minus 81 plus 27, you get minus 54. And that's exactly what we got on the synthetic divisions. Okay, it's going to be the same answer there. All right, the question number 7, which is the last question here, I believe. So let me just get that. Okay. So question 7, the speed of the boat in still water is 24 miles per hour. So meaning that, if you have a boat and there's no water current, okay, just still water, and it goes about 24 miles an hour. So if the boat travels 54 miles upstream, so if you go upstream, you're going to lose speed. And then if you're coming down, okay, I mean if you go up 54-mile stream, it's the same time that it takes the travel 90 miles downstream. Okay, so we're gonna find the speed of the current. Okay, so we don't know what the rate is. Okay, of the current, water current. So there gotta be, if it's gonna be a river, then there is a speed of the river that's coming down. We want to find that speed, using this information that we are given. So only thing that we know here is that if there is no current, then this boat can travel 24 miles per hour. So the other condition that we are given is that if the boat travels 54 miles upstream, in the same time that it takes the travel 90 miles downstream. So if you look at your page, you should have given the box that I want you to fill out. Okay, so that's what you had. So in this case, let me just put boxes here. So then I have the upstream, then I have a downstream. And the first column was the distance. And then I had the rate. Then I had a time. Okay. So the going upstream was 54 miles. And the going downstream was 90 miles. Now if I call the x equals to water of current, the speed of the current, of the river, okay, you can just, so if you go upstream, then you're going to lose this much speed, right? So, but we know that the boat speed in still water without the current is equal to 24 miles per hour. So without any current of the river, the boat speed is going to be 24 miles per hour. So if the boat goes upstream, then it's going to lose that much speed. In this case, we don't know what that is, but x. So the rate will be whatever the boat speed, subtracting the speed of the current of the river. Now if you go downstream, then you're going to gain that much speed of the current of the river. So if you want to find time, then because distance equals to rate times the time. So if I want to find the time, you simply divide the distance by the rate. So that's why what we're seeing here. So the distance was 54, and the rate here is going to be 24 minus x. And same thing over here. This time was a 90 mile downstream, and you're going to gain the speed of the current there. So this is going to be over there. Now it also says the going 54 miles upstream is the same time that it takes the travel down 90 miles the downstream. So whatever that time that goes upstream is the same as the time that comes down in the downstream. So we're gonna have to make that like this. Going up time is the same as coming down time. So the going up time is going to be 54 divided by 24 minus x. And that's going to be equal to coming down time, which is what, 90 over 24 plus x. Okay. Alright, so we need to solve for x, and that should be our work there now. There's a couple of ways we can do that. We can eliminate the denominator by multiplying both sides by 24 minus x and 24 plus x. So why don't we just do that? Or you can just cross multiply if you like. So we're going to multiply both sides by 24 minus x times 24 plus x. And now we're going to multiply this to the entire equation. So you got 54 over 24 minus x equals to 90 over 24 plus x. Okay, so now we're going to have to multiply this. So first term on the left, 24 minus x and 24 minus x, that cancels out. So that's just giving us the 24 plus x times 54. Same thing on the right, 24 plus x cancels out and give us the 90 times 24 minus x. So now let's multiply these out here. So let's look at the 24 times, 24 times 54, we get 1296. Okay, so you got 1296 plus 54x. Now let's look at the 90 times 24. 2160. And you got minus 90x. Okay? So we're going to add 90x on both sides here. So let's just do that. So then I have 1296 plus 144x. And I have a 2160. Now we're going to subtract the minus 1296. So on the left, I have a 144x. Let's find out what will be the 2160 minus 1296. So that should be 864. And then we are going to divide both sides by 144. Okay, and if you do that, you will get 6. So what we're saying here is that the current of the river is the 6 miles per hour. So if you go up, okay, and you're going to 24 minus 6, so you're going to end up with the 18 miles per hour going upstream. And if you are coming down, okay, then you got 24 plus 6, you're coming down with the 30 miles per hour. Remember that the speed of the boat is a constant at 24 miles per hour, because the current of the river is coming down is 6 miles per hour. So if you go upstream, you lose that 6 miles per hour. But if you're coming down with the river, you gain that 6 miles per hour of the current. All right. So that was it, and I want to make sure that everyone go through this, okay, understand, and we'll do a couple of more exercises, but we'll talk about that in class. Okay, so I'll see you guys in class, and then I'll answer any questions you guys have. All right, thanks.